Okay, so this problem is basically a buoyancy problem, and the basic formula for buoyant force is equal to rho vg, where rho is the density of the liquid that the thing is floating in, right? And can't write today. And v is the volume, not of the thing that's going into the liquid, but it's the volume of the liquid that gets displaced. That's the key. And then g, we know g already. This is the gravitational field. That's 9.8, right? Newtons per kilogram. So what's happening here, this kid just wants to make a thing that'll keep him afloat, right? So that means the water level will just be barely there, right? So this volume needs to equal that volume right there. And so let's think of this in terms of free body diagram, right? So we can figure out what the buoyant force needs to be. So there's the weight of the kid, and there's the buoyant force. And these two forces must be equal to each other because the kid's not accelerating one way or the other, okay? So that means that I can substitute in, because weight is mass times g, I can put m times g equals rho vg. All right, so now we said before I want to solve for this volume here. So whatever this volume is how many bottles he's going to need. So I can divide over rho g. Rho cancels out, g cancels out. So the volume of the displaced liquid is going to be the mass divided by the density of water. And the mass of the child, it says, is 32 kilograms. And the density of water is 1 kilogram per liter. So that means that he's going to need 32 1-liter bottles. Since each bottle is 1 liter, 32 1-liter bottles will give him a displaced volume of 32 liters, and that'll just get him able to float.